Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Bocek, and today in the news we have the following topics. We have a bit more blockchain and Web3 hate. It's the following article here. This article here. And the article is about blockchains, that is dangerous nonsense. He then tries to convince or tries to argue why blockchains are bad. He says that blockchain as a technology is already deeply flawed in its basic concept, and he mentions a few points. For example, in code we trust. That's the opposite model of a centralized system where you have engineers building the system. You have to trust those who operate this platform. And in the blockchain world, you have the smart contracts. They are published. You can verify them. So there's in code we trust. However, he argues that this code is written by humans as well. So eventually we'll have to trust humans as well. Also, he has he mentions energy usage, which indeed is quite high for Bitcoin in Ethereum. Ethereum hopefully will change soon from proof of work to proof of stake, but proof of work is a huge, it needs a lot of energy. And he mentions that proof of work still used by all relevant public blockchains. I would argue those are the minority. Most of them either switched from proof of work to something else or directly started with a more energy friendly consensus mechanism. Then there was based on, or it looks like a replay to that. There was another article here. You don't need a fucking blockchain. And this is clickbait, just to get your attention. It's not about not needing a blockchain. It's basically telling what a blockchain is, how it can be used, for what it can be used. There are some very nice statements in there. For example, building distributed system, building distributed consensus in a trustless system. This is what blockchain is about. And also blockchains are all about collaboration without trust, which I also tend to agree. And also giving users control over their data, their identity, and their systems. That means in the crypto space, if you have your wallet, typically it's a non-custodial wallet if you have any funds on them, and you control these assets. That also means if you lose the keys, if you lose your phone, then the money is gone. There's nobody to call. But you have the full control. Nobody can take it away from you. So you're in charge. Has pros, has cons. And my take on that is blockchain is a tool in a toolbox. It makes sense for some use cases. It doesn't make sense for other use cases. And my advice, as always, if there's a need for blockchain, if it makes things simpler, use a blockchain. If it doesn't make any sense, if it would increase the complexity in the system, don't use it. So it's as simple as that. The next article, quite an interesting idea actually. It's about BGP and blockchain. So it's about securing the BGP with blockchain. This is a very short RFC, so probably this is only based for a discussion or used as a discussion. The question is it possible to use a distributed ledger such as a blockchain to secure BGP? BGP is a border gateway protocol. You can read about this here. It's how the internet works. So multiple autonomous systems are interconnected with each other over the BGP protocol, and this is also a distributed protocol. And there are things that can go wrong, that already went wrong, especially BGP hijacking. So the last BGP hijacking was in February, and there was a BGP hijacked that was belonging to a South Korean cryptocurrency platform, and it was redirected, so the attackers could steal cryptocurrency worth roughly 2 million US dollars. So these are the results of BGP hijacking. BGP hijacking happened also before the cryptocurrency boom. So here we saw when it started, it still is happening, and this is an approach, a BGP blockchain, to initiate the discussion. Could it help? Could a blockchain help to secure the border gateway protocol? The next article, it's Project Loom, and here it's about this side here. Here I want to make the point that systems these days, they're quite fast, and if you can scale, first scale vertically. The systems are amazingly fast, and this project Loom, they are trying to achieve 5 million connections, to keep it open, to have a client server ping pong messages, and to see if it works. So there's a new addition in Java 19. They will have something similar that Go is having with those virtual threads. So they're not actual threads, but virtual threads. Only if they're needed, there's a new thread created. Otherwise, it will run on the same thread. And they did an experiment. They run 5 million connections, and they checked, does it run stable, and they reported yes, they were 5 million connections. They run the test for 40 minutes without incidents, without any kind of connection dropped. This was on a bare metal server and also on EC2. They did the same experiment. They run it for 35 minutes. Also, every message was received, so there was no connection dropped, and this shows that a single machine is capable of having clients and servers that can process 5 million concurrent connections, which is quite a lot. And I believe in the future this will increase. We will have better machines, better hardware, so the vertical scaling gets easier and easier, and horizontal scaling, if you need horizontal scaling, then you would need to have a massive load or some kind of calculation which is not easily done, but plain open a socket, send a message, reply, that's pretty fast and can be done on a single machine. The last article is about Backblaze. They are releasing drive statistics, so they use quite a lot of hard drives. So you can buy storage space on Backblaze, and every quarter they show the numbers, which drives works quite well, what's the AFR, which means the annualized failure rate, and they show these drives. Unfortunately, this time they only show spinning disks, so hard drives with up to 16 terabyte. I would love to see how SSDs, how many drive failures there we see, but their conclusion is that drives are quite reliable. So these are the best manufacturers. For example, WDC with their 14 terabyte model has an annualized failure rate of 0.33%, which I think is quite low. I believe SSDs, those will be even lower, but yeah, I need to wait for their numbers.